My guest for this episode is science writer and communicator Kat Arney. She is one of the UK's foremost science communicators, and today we're going to discuss that process for how science finds its way out of academia and into people's lives, for better or worse. Kat, hello.
Hello, thank you for having me on.
No, it's a pleasure. It's been a while. You've written for Tes in the past, and we've had, you've written some really, really amazing features for us, some that have been award-winning, so it's good to be reacquainted with you. So I think the best place for us to start when we're talking about science and research and its impact on the real world is when a scientist is undertaking research. Is it a lazy assumption to assume that every scientist wants to change the world, that they want to have a practical impact on life?
Well, I think it's a lazy assumption to assume that all scientists are the same. And it's sort of the thing that I always try and get across to people is like, scientists are humans. Science, for all the talk of like just led by the science and evidence, like science is a human practice that is done by humans. Yeah. And it's inevitably and incontrovertibly linked to our humanity. So you can't say, well, scientists are like this, scientists are like that, all scientists are like this, because they're as different as any other humans are. So yeah, some are massively driven by ego, some are massively driven by altruism, some are somewhere in between, some just want to get through life and just get paid and do other things, right? Like all of us, we all have our own things that motivate us. So this, I think it's a canard to say that, the motivation for science is entirely altruistic and wanting to change the world. In many cases it is, and a lot of scientists I know are really driven by wanting to see impact of their work. I want to find the treatment for cancer, particularly, or any condition, particularly if they've got a personal connection to it. I'm going to beat heart disease because that's what killed my granny. And others are just really driven by curiosity. And I think there's a lot of scientists and researchers that are like that. They just want to understand the connections and complexities in life. And certainly for me, when I was a scientist, that's what I wanted to know. I was a developmental geneticist, and I wanted to understand, how do you unfold life from one set of DNA in one cell, a fertilized egg? How do you build a baby from that? And it turns out it's really complicated. So I gave up and became a writer because that's a lot easier. But that the curiosity driven thing, like wanting to know how stuff works and sort of wanting knowledge, that was my driver. But for other people, they had, even in the same lab, had different motivations. Some people, it was literally just a job. It was what they'd gone into and they were good at it. You get the sort of the people who are like, yeah, I want big papers and I want to be like famous and I want to win a Nobel Prize, blah. And other people who are like, yeah, I want to set up a company and a spin out and develop some kind of new therapy. But yeah, most people, know that science isn't going to make them massively rich. So money's not a massive motivator. But people have very different motivations, as we all do.
Do they, if they do have, a curiosity, like you said, or if the motivation is to for a Nobel Prize or to spin it out, are they motivated to place those experiments in as real circumstances as they can from the off? Because I think one of the things from education research we see a lot is that the research is done in laboratories a lot of the time, and a lot of the time with undergraduate students, not necessarily schools, and the variables get so isolated to find one particular thing that the reality, they may set out to be quite a realistic scenario, but the reality sort of edges out of the experiment. I mean, is that normal? Is that the scientific process, I guess, is the question.
Yeah, well, there's sort of different levels of it. So, I mean, the area that I really know about is biology and the life sciences, but pretty much every field of science has the whole spectrum from incredibly theoretical all the way through to extremely practical and sort of applied, in the case of biology, like really applied clinical and population research, going all the way right down to the theoretical biology, doing statistical calculations on populations or trying to understand the fundamental mechanisms, the molecules within inside a cell. And physics has got the same, going all the way from, the maths, theoretical physics to, putting a rocket up into space is a physics project. So you've got everything. So I think that all these disciplines, it's about what different level. And science, pretty much almost all levels, has to rely on some kind of model. There's a very famous story about a king who said, like, I want a map of my kingdom. And so his cartographers went away and they drew this map of the kingdom. He's like, no, I want more detail. I want more detail in it. And they went away and they drew a bigger map with more detail. He's like, no, this doesn't capture everything. I want more detail. And in the end, the only map that was really accurate was a map that was the size of the kingdom with everything on it. So, all of science is basically trying to kind of control as many variables as you can to get some kind of insight. I think particularly in the life sciences now, we're trying to move towards the idea of like real world medicine, real world outcomes, what actually matters to people. And those are hard to measure because people don't always behave like you want them to. They're not neat and well behaved like a laboratory mouse. But it's sort of accepting that every model and every system has its flaws, but being honest about what they are. And then, all right, what's the next experiment that you would do to try and figure out some more? Science is not a one and done. You don't have the definitive experiment that just shows you everything. It's always a step in a process towards, okay, right, well, that showed us that. Where do we go from here?
Yeah, and I think in education, they look to health and life sciences a lot to say, look, they're doing some really complex research. And there's a guy called Professor Jon Severs in the US who wrote something for us recently and said he'd love to do more like that, but the cost and the timeframes involved in real world research, he said the money is just really not there for for education at the moment. And if that is the case, and these guys, let's say that the scientist does want to make a difference, the translation exercise of what is necessarily a contained experiment to find a result and the practical endpoint, how much of a responsibility does the scientists themselves have for that translation process, do you think?
I mean, personally speaking, there's two kind of different things here. So there's the sort of the translation in how do you turn something that's an idea or scientific concept or a scientific result, how do you actually develop that into a real world application? So again, in the life sciences, we talk about translational research being how do you take a discovery in the lab through to being a treatment and then all the testing that you'd have to do with that. But I guess as well in the context of something like educational research, it's how do you take the results of psychological experiments and then translate that into an intervention or some kind of idea or program that then you can bring out through schools. And actually, when I was writing for Tes, I did a lot of science-based features. I talked to a lot of educationalists. And the thing that shocked me, and I kept coming back to all the time, is how little and how poor quality the actual educational research is. There's a lot of people writing a lot of books and having a lot of ideas based on that kind of, the psychological literature. But if you apply the same rigor that we do in the life sciences, like, have you actually tested this in a kind of randomized trial or different settings? And most of the time the answer was no, but it seems plausible, or no one's got the time for doing that. Let's just make a nice book and a nice program about it and roll it out. So I think where I think it is really important in the language translation. So how do we talk about these ideas that are coming from research, talk about them to the public? I really think everyone involved in science has a responsibility to do that. And, not everyone's going to be an amazing science communicator, and it doesn't have to be like, oh, I'm going to do a TED talk or whatever, or write loads of blogs. It's more about just that commitment to explaining what you're doing, what are the limitations of what you're doing, where could this go next, and how does it work, and explaining the process behind it rather than just we found a thing, here's my big idea, buy my program, roll it out.
Yeah, well, we've had both Professor Carol Dweck and Professor John Hattie on the podcast, and they almost seemed surprised that something they deemed to be an academic exercise, and often in Carol Dweck's case, not something that was connected to education in her mind, was taken up by teachers, and they went, oh, well, now it's been misinterpreted. I mean, the blame was very much put on the teachers for that misinterpretation. I guess I better do some translation work. And it seemed like an afterthought. And yet other people, we've had on the podcast, people like Daniel Ansari and Jesse Ricketts do lots of research with teachers because they're worried about the impact. And I don't want to get into a right and wrong necessarily, but that spectrum of sort of viewpoint, is that normal across research, or is that something, as you say, that might be a little bit particular to education?
Well, I think it's, come back to my original point, like everyone's different and everyone's got their own views and their own capacity to do this stuff. Because like communicating things well, it really takes time and it takes skill and it takes effort, and all of those things eventually equate to money as well. But I think, so when I spent 12 years working at Cancer Research UK in the science comms team, and one of the jobs that I put on myself to do was to be kind of reading the comments. Everyone says like, oh, don't read the comments, but I would read the comments under the Daily Mail posts. I would read the Facebook stuff. I would read everything, even the stuff that was controversial or aggressive, because to try and find out what people are saying, and then to think about, all right, what are the misconceptions out there? How can we address them without wading in and going like, you're wrong, that's not right. But like, okay, there is a discourse here about X. How can we think about in our communications that we actually sort of address X because we know it's an issue? So I think it is a bit of a dodge to say, if you're going to put out a book or put out some research and promote it and want it to be successful for the reasons that you might want that to happen, you do have to think about how are people going to take this. And certainly in comms, I'm doing a lot more work in sort of science comms and communication, realizing you can't control what people think or say about your stuff, but you can nudge them in the right direction. And you do that by providing clear information that helps people understand, what does this show? What doesn't this show? How might this be applicable to me? Is this really not applicable to me? You have got to think about it a bit more rather than just go, well, I made a thing, put it out into the world, make of it what you will, because then people will, and then you can't really complain about it.
Yeah, I see. And I guess what happens in education a lot, and there's been a lot of debates on this about social media, is that people find a favorite idea from research, and then they get upset when other people mutate that idea. And they say, well, that's not what it's about, and it goes back to what you were saying there, where you can't control how people interpret it and put it into their own context. And that's complex, right? There's a complex relationship, especially in education, where you have very high stakes and an enormous number of variables.
Yeah, and and a lot of these ideas are kind of sexy and they sound plausible. Like a lot of, I'm always amazed by, particularly in sort of the psychology and behavioral sciences, and like how plausible things sound. They seem true. A lot of stuff seems true, and then you go, well, has this been tested? And it's like, well, no, it hasn't, but it seems right. Sure. And the other thing that I think is really important to point out, that a lot of the ideas that come out of the research world, they do lose the kind of the caveats, the gray area. It becomes like, yes, no, this definitely not, yes, black, white, this is the answer, this is what you do, and everyone will respond in this way. When of course, intuitively we know that doesn't happen, but we want to believe it happens. And the other thing as well to highlight is that a lot of studies, they will tell you things on a population level. If things are based on like statistics and you go like, well, 78% of people like this, that still means there's 22% of people who don't. And then it's, what does that mean on a personal level? So kind of the journey from population to personal, I think really gets missed, because so much research is based on, because you want it to be statistically accurate. You've got to have large numbers, you've got to have the statistics, but then it's like, well, what does that mean for me, for my child, for my classroom in my area? Can you transfer this information from a classroom in Atlanta, Georgia to Burnley? Well, maybe not.
And why do you think a lot of the mutations happen through simplification? So like, I mean, teachers don't have a lot of access to the original studies because a lot of them are paywalled, which is a separate issue. I mean, there's a big call out there for a lot more free science. But what tends to happen, and one of our columnists, Christian Bakove, talks about this, is that paragraphs or even chapters become sentences in the simplification process. And I guess part of your job is an accessibility is a better word, right? So how do you get accessibility without an simplification?
Yeah, that's something I struggle with every single day as a science communicator. It's like, how do you not, I hate the phrase dumbing down, but it's like, how do you communicate an idea and the importance of an idea and the limitations of an idea without stripping it of nuance and detail to the point where it's just meaningless. You know, we sort of used to joke at Cancer Research UK that people just take so much detail out of something that it just become like, oh, this is a thing that sticks to a thing in cancer. And you're like, what does that even mean? So it is, I think as communicators, it's working out what are the actual important details here. What are the important caveats? I think, you know, scientists can want to shove in loads and loads and loads and loads and loads of caveats. That's how scientists roll, she says, generalizing. But, you know, what are the actual important caveats? But what are the important details to make something that's not completely generic, not like, yes, do this, black, white. So how do you think about how to communicate that message? But we live in a very increasingly short attention span era. We communicate in tweets and headlines. And yeah, I don't have any really massively great answers for it because it is really, really hard.
I think what complicates it sometimes is, I've used this analogy in the last 6 months when we've been talking to a lot of scientists on the magazine around COVID and the risks around school, is that you get a lot of scientists who you say, you know, can you fly? For example, if I jumped out a window, would I fly? And they'll say, well, there's a 0.0000000% chance that you might. And I mean, that's not a real example, but it gives you a sense of the sort of the hedging, I'd call it, that goes on. It's like, oh, I don't want the headline being me saying you can't fly and then someone ends up flying the next day and I look like an idiot. And that cautiousness from academia, I can understand. But in your role and in my role as you know, I'm not a science communicator as such, but as a journalist, it can be incredibly frustrating and confusing for the public if things that have a very slim chance of happening are put on in an equitable way with something that's likely to happen.
Yeah, and there's kind of two parts there. So the first part is in the scientists communicating to the journalists, and then the second one is like the mediation job that journalists then do. The problem is there's kind of like, you know, falls at every step. So I think one way that scientists certainly don't make life easy is trying to put in loads of numbers, loads of like, you know, well, yes, there is a p 0.05 statistical probability, whatever. It's like, that is not helpful to anyone, i.e. most people who don't have knowledge of statistics. And so when I'm doing science comms training with researchers, it's like, let's think of words that we can express that you're comfortable with, that express these statistical concepts. You know, if it's 95%, just say most. If it's 99%, that's nearly all. You know, if it's 0.1%, it's hardly any, virtually never. So that's like, how can you actually find a phrasing of words that the public gets and understands? Then the next step is like, as a journalist, you know, you should know enough about the story and know enough. I think all journalists should have a bit of statistics training, to be honest.
Definitely. I think
the Royal Statistical Society does offer that. But like when a scientist is saying, well, it's a 0.001, so we could say virtually never. So it's like, all right, say virtually never. Then the journalist doesn't go, right, well, I'm going to say never. It's like, you know, but don't make it too hedgy and put loads of numbers in it, because no one gets that. But so it's about finding forms of words that people understand effectively what they mean, or like, practically speaking, this isn't something you need to worry about. You know, if you're doing this and if you're doing that, yes, you know, there's a chance that this might happen. But trying to find forms of words that aren't full of numbers and statistics, I think, is really important.
Do you think in the past 6 months, where you have such a highly emotional topic as school reopening, schools closing, and there has been a struggle with the science, mostly because the government keeps talking about the science, which, as we've talked about previously, is a complete empty phrase, but also because there's been some hedging, because they won't say, you know, it got better when they would say, when they started talking, I think it was some good work from one of the statisticians at one of the London universities, was trying to discuss age group related statistics and then comparing those statistics, because not everybody knows the flu death rate, for example. Not everyone knows, you know, the other instances that can happen to you. So there's no comparison there. But do you think, because it's an emotive topic, perhaps the academia and perhaps the science has been a little bit more cautious than perhaps they would have been, using those phrases, perhaps slightly more reluctant because, you know, they're on the front page the next day? You said children never get, well, hardly ever get it, or I've forgotten the exact phrase you used. Here's a
Virtually
child.
never.
Yeah, virtually never. So does
Yeah.
emotion really cloud it?
Yeah, I think so. The challenge is certainly in communicating anything, like stories always trump statistics. So, you know, the story of here's the one child that did, it's always going to trump like that child is the 0.001% out of all the children that didn't.
Yeah.
And that's always going to be a challenge. And so you sort of have to try and, you know, because no one wants to see a story about like, here is 10,000 children who do not have this. Like, that's not a story. So there is certainly a challenge there. And I do want to pick up on what you said about kind of being led by the science. And I think there's this idea that like science can tell you, even with the statistics, like, you know, yes, no, here's like, you've got a 90% chance of this, a 60% chance of this. This is the science, right? And so you do this or you don't do that. And like, well, actually, if anything, the pandemic should highlight that science, I'm going to bang the drum for this so hard, science is a process, not a product. The fact that one paper has come out that has some numbers in it, that is not the last word on this. And really explaining like, okay, so how did people get to those numbers? What do they mean? What does it involve? Why are those numbers different from some other numbers? You know, and this is kind of complex stuff if you're just trying to look at the papers, but it is the job that science communicators and scientists and journalists should be trying to engage with about, you know, what was the journey that got us here? And then when new evidence comes out, how does that fit in? How does this build on this? So, you know, you can argue for like greater public science literacy, but I think journalists also do have some responsibility for, you know, engaging with scientists, engaging with science communicators to think about how do we actually explain this in a way that does get across that this is an ongoing process of emerging data in a disease that we didn't know anything about in January.
Yeah, I mean,
and are trying to make decisions about how to live our lives when there is, and that's the other thing, there is no right answer. And a scientific paper will not tell you a right answer about what you should do. And it won't tell the government what they should do. It won't tell you personally what you should do. It's kind of information that you have to integrate. And, you know, and this is why it's such an impossibly hard job for the government, for schools, for policymakers, for parents, for teachers, because this is the pure thing. You know, science gives us evidence. It doesn't tell us, therefore, you must do this.
I think there's a good examples of that in the COVID pandemic for schools. There's a German study that was cited all over the place where one of the prominent German epidemiologists said that children had as high viral load when they had COVID as anyone else. And then that study was traded against another study which contradicted it. And you had study versus study. And it was very hard to understand the consensus. And there were some very good people who were trying to give you the consensus. But all that was happening was, look at this study though. You're saying that, but this study says this. And that must be very sort of annoying, I guess is the word, for an academic who's trying to consolidate, who's doing all the things right that we've talked about.
Yeah, I mean, during the COVID pandemic, we're basically seeing like all the challenges in SciComm ramped up to 11.
Yeah.
So, you know, there's been long running bubbling conversations in the science communication world about what about these things called preprints, which are basically where scientists write a paper and they put it on the internet. And it's like, this hasn't been peer reviewed. It hasn't been checked. It's kind of gone through the processes of quality control and rigor that scientific publications do before they end up in journals. And usually it's that process. They go through all that and then they get published and then we do all the publicity around them. And that's how they get to the public. But now like preprints are just going up like this. Journalists are just reporting on them. And you're like, this is just a PDF. Basically, this is a PDF that someone has written and put on the internet. Yeah. It's not gospel. And a lot of them are turning out, I think there's been a study I saw from some science writers, like a lot of them do turn out to be, this is pretty much how the published paper is once it's gone through peer review, which is not a perfect process, I will say. But some of them do turn out to be nonsense. And it's often those that get the most because they're controversial. Yeah. So that's a big problem. And then the other problem that we're seeing is, and I experienced this a lot in the cancer field, is that, oh, scientists say this, but scientists say that. Don't scientists agree on anything? You don't know anything. You don't know what to do. Yeah. But, well, yeah, because evidence from different studies can be contradictory all the way down. So it's the job of scientists to then go, all right, well, what's the next experiment we need to do to try and figure this out? And like, nothing is that absolute line in the sand of like, this is fact and immutable fact right now.
Yeah. And I think a good example of that was the face mask debate. And I know from my own sources that a lot of the confusion around face masks was around science around experiments with face masks and behavioral science. So what does a face mask do in terms of COVID transition, but also what does a face mask do to someone's behavior? Do they maintain a social distance if they stick a mask on? And if they stick a mask on, what is their process of risk assessment? And I guess that question has some multiple parts. But firstly, I mean, in your mind, behavioral science, I guess some people think, oh, that's not proper science. What is behavioral science? And versus some nice laboratory study with a mask, they're not comparable. But what's your view on it? Are they comparable?
Yeah, I think we really have to, with something like this that is absolutely real world outcomes on the ground now, live, people's lives, we do have to think about how is this stuff manifesting in the real world? And that is the role of behavioral science, to figure it out. And so I think that, there is a bit of a schism of the kind of led by the science, and like, we should be led by the proper science, by the modeling and the lab studies, and not by these weirdo psychologists. But like, we are humans, we are all humans, and we behave like humans. And I think there was a study I saw from, I think it was a US university. They were trying to model what the potential infections could be like in their university when the students come back. And so they got the physics department to do it. And you sort of look at the model, and it turns out the physicists just assumed that no parties would happen. Now, I don't know what that tells you about physicists.
Yeah.
I sort of digest, but you have to really understand how this system is working. There's a very famous example in physics about how, I think it's probably a joke rather than an example, where a farmer goes to the university and says, I want you to help improve the yield of my cows. I want you to help make my cows better and more milk, and I'll make more money. And the physicists kind of start a paper by going, first assume an entirely spherical cow.
Yeah.
Like this is not practical or applicable. And in this situation, we really have to have, like, we've just got to do our best. And I said, there's no right answer here. I think we're going to get through this pandemic by just trying to make as many right-ish decisions in the right direction as we can, as a population and as individuals. And that's very difficult, because sometimes you don't know what the right decision is.
And as a teacher, assessing their individual risk, and then as a head teacher assessing the risk to a school, the time for a head teacher, the emotional side, also, they're also thinking about personal risk, and then they're also thinking about, well, there's all this science, what do I do? Like, do I just follow the government guidelines to the dot and assume they've got it right? Or, I've got parents throwing a study in my face saying, this is why I'm not bringing my child back to school. I mean, there's no right answer to this, and is there any guidance you can give a head teacher in how they might best try and summarize that or get to grips with some of these questions? Or is it just best to follow the government advice and, assume that the science has been done?
I mean, speaking as like, I'm a woman just sitting in a bedroom in Maidenhead with a degree and a PhD in biology and not a public health expert, I would never dream of saying, do this, don't do that.
Yeah.
It's very challenging because, the government guidance, they do have, I use this phrase carefully, they do really have experts working there. This pandemic has flushed out an awful lot of armchair experts.
Yeah.
And, the government, I think they have made missteps. I think they have made poor decisions, but you have to assume, at least at some point, that the heart is in the right place. And the guidelines that we have, I'm not exactly even sure how they apply in schools, because I'm not connected to the educational world anymore, so I can't really talk to that. But I think more generally, we do have to try and integrate and balance everything together. And it's sort of, there's these guidelines here and these guidelines. So I think one of the problems that we're all facing is that there's different guidelines for different parts of our lives, but we all live integrated lives. You've got guidance about pubs and workplaces and guidance about schools, and this doesn't all sort of fit together. So I think there is a challenge there of how society should be managing risk. And I think that certainly, like, the government hasn't done a great job of accepting that we all live complex lives with multiple exposure potentially in it. So how do we balance that, and how do we balance that as a society? What risks are we accepting? What risks are not worth it? How do we balance exposures and the potential long-term impacts on schools, impacts on workplaces, impacts of the economy? It's the world's most horrendous equation. And there are no right answers to it. We've just got to try and figure our way through it.
And you, sort of a final question is, as a teacher listening to this, and you're trying to extrapolate, like you said before, population statistics down to what's my individual risk. You said in terms of cancer, in terms of the health sciences, that translation is probably not a simplistic one you can make. And would you say the same is true of this? That try not to, because it's very anxiety inducing. You've got 10% more chance of hospitalization with COVID if you have, I don't know, diabetes. I mean, that to anyone listening, that's a stat off the top of my head. It's not a real stat, but the point is that you translate that to your own experience, and that's natural, of course. But you mentioned earlier that it's not necessarily correct.
Yeah, and that's the thing, is there are population level statistics, and there are your personal, like, what happens to you, and you kind of only really see that. You're an n=1 study, and you'll only see that in retrospect because you'll see what happened to you. So I think we can use this kind of information to try and judge how risky we think things are, what kind of personal level of risk we're prepared to accept. And we do accept risk every single day in our lives. And that's the important thing. Like, COVID is not just the only risk that we face. So, every time, if you're a smoker, every time you light a cigarette, you are accepting a certain level of risk. Every time you get in a car, you're accepting a certain level of risk. Every time I don't know how many of your listeners go skydiving or horse riding or riding on a bike, you are accepting a certain level of risk into your life. And quite often we don't even think about what those risks actually are. The thing with COVID is, like, it's just slammed in your face every single day. Risky, this, bad, risk. These numbers, that numbers, your risk. So we are having as a population to grapple with risk, and big stuff risk, like risk of mortality, risk of serious illness, risk of long-term illness, in a way that we never really have before. And almost the immediacy, it's throwing everything we know around. So with something like cancer risk, you're like, well, I'll have a cigarette now because I might not get cancer for like 35 years. And then you're like, well, if I go to the pub, will I get COVID by the weekend? Like, this is a much more immediate risk-based decision. And it's very, very difficult. And we are really being faced with it. And I don't have any good answers because I think it's incredibly hard for everyone.
No, I agree. And I think it's something that we'll have to learn to live with, that risk. And I think perhaps a better understanding of general risk is useful, comparative risk, I mean. And what the pandemic's highlighted for me is that our comparative risks, unless you've had direct experience of ill health or other situations, maybe a car crash, you don't understand the levels of risk. And how useful is it that you have scientists in the papers saying, well, if you're in this age group, you've got more risk of dying in the bath than getting COVID? Is that a helpful way of bringing in comparative contextual knowledge or not?
Yeah, I think the side of it there is it's about helping you figure out what you want to do, and also how much you want to worry about things. Because ultimately, like, risk is about worry, and there is absolutely huge anxiety at the moment about all of this kind of stuff. It's the most anxiety inducing thing that I think I've ever experienced in my life. So trying to put things in proportion is really important. And so I think the population statistics can try and help you shape your behavior. So knowing that if you do this, if you wear a mask, if you wash your hands, if you maintain social distancing, you bring the chances of becoming infected or infecting others down. If you choose to do, if you are of this age, if you have these underlying health conditions, your risk is higher. So maybe you want to try and do more of these behaviors that we know reduce your risk. If your risk is much lower, then be proportional about how worried you should be. So it's about not panicking when you don't need to be panicking, and taking appropriate measures when they can actually do something for you to feel in control of your risk. So I think that's where those population level things can help. But ultimately, like, each of us is an n equals one-off study. And you sort of do have to choose your own adventure to a certain extent. But at least by saying, here's the comparative risks, here's how much difference we know these interventions make based on the available science that we have right now. So people can try and figure out how worried should they be, what do they think will really make a difference, or help them to control their own risk.
I think it's a very sensible message to end on, and hopefully a very comforting message for the listeners out there. But before you go, you've got a new book out, and it would be remiss of me not to talk about that a little bit, because it is a fascinating book. Do you want to tell us a little bit about it?
Yeah, so this book, it's called Rebel Cell, Cancer, Evolution and the Science of Life. So I have brought a book out about cancer in the middle of a global pandemic. So great timing all round. And it's a book, I mean, it sort of does explore what we really think cancer is. Where did it come from in our evolutionary history as a species, the history of life on Earth? Cancer is a very old, ancient disease. It's not just a human disease. It's not just a modern disease. So I've been trying to really put it in that context of the whole of biology, understand where did it come from, how does it evolve, why do some of the treatments we have work, why some of them don't work so well, why does it come back after therapy, and then look into the future, how can we use more evolutionary based ideas, ecology based ideas to understand this cancer as a biological phenomenon, and then find more effective ways to treat it in the future.
Oh, I'm going to put an order in right away, but I think it's probably got some very good lessons that can come out for educators as well on science in general, and just, it's something that goes along with your other book, which is Herding Hemingway's Cats, which is really an attempt to make very complex topics and highly emotional topics. Cancer and genetics are very complex and very emotional, more accessible. And I think that the more accessible something comes, like COVID, is it becomes less anxiety inducing. Hopefully it leaves you less anxious.
Exactly. And there's a quote, I think it got cut from the book in the end, but it's I think it's a sort of sub quote from Marie Curie, who says, nothing in life is to be feared, is only to be understood. And I think that works across so many parts of life. And, it's certainly applicable to cancer, and I think it's applicable to COVID as well.
Well, thank you very much, Kat, for joining me.
Absolute pleasure. Thank you.